The next module for my demonstration is the Iot Current Sensor. I'm using a MagnaLab SCT0400, which is a current sense transformer. This is basically a clip-on module which you can attach to any cable that you want to measure the AC current flowing through. I'm using an Arduino Nano here, and it's a minimalistic circuit at the back end, right? And I'm using a cheap RF module to just transmit the current to the base. The next module is the Appliance Monitor. Welcome to Shaky Cam. I'm doing this by hand. I have the Enotion module, which is connected to my air conditioning unit's power LED. Here we have the same module taken off. It consists of a resistor and an LDR, which have been directly soldered on to the Enotion module. This is the Enotion temperature STM330 temperature and relative humidity module. I'm using the capabilities of it to transmit luminescence data. Here you can see, as long as the LDR is exposed to a lot of light, the air conditioning systems the status is set to on. If I cover it using a hat, why a hat? Because I don't want to touch it. If I can touch it, then some kind of conduction may give it a false positive. And if I force it to send another teach-in telegram, which is going to update values, and you can see that the air conditioner system now goes to off. If I again expose it to light, let's hope the battery stays, again send a teach-in telegram, and the air conditioning system is now set to on. So I am getting luminescence values, but I'm translating using rules in OpenHub to convert it into an on-off state for the air conditioning system. That's the capability, and that's the power of the rules. You can convert values, analog values, into digital logic according to your requirement. So this is the next module for my demonstration. This is the Arduino Mqtt sense and control for the workbench. There is a PIR sensor which detects my presence in the room. If I am absent, then it'll take about 3 seconds. There we go. 1, 2, 3. There we go. So if I wave my hand in front of it, it'll switch on the lights. If I use my Android cell phone, alright, and if I switch off the Wi-Fi, now when I switch off the Wi-Fi, it can detect that the owner, that's me, is not present. So there might be some other kind of thing going on. So even though the status here says workbench present, the lights will be switched off because the Android phone has been detected as being absent. And you can see that Interpret at Home says off. I just disable the automatic control on the system. Now it has gone into totally manual mode. Now I can use my laptop, and using the OpenHub interface I can probably switch it on. The alternative is that I use one of the rocker switches, and voila, now I have a wireless control, manual control over my light switches. Again, I can also use the same rocker switch to switch it off. This particular system is connected via Ethernet to my router, which connects again to the OpenHub system. Inside, I'm not going to go into the details, but inside this box there is an Arduino with an Ethernet shield. There is an RF link which receives the data from the current sensor. And I also have a secondary board which uses a switching regulator instead of the standard 5-volt linear regulators, because this one has a lot more power savings involved with it. There is an Ethernet cable coming through, and I also have a pair of wires which has the 12 volts, the common ground, and 2 logic levels which transmit to underneath the bench where there are the relays placed. And that's where the switching actually occurs. So I'm not putting the relays here, I'm actually putting the relays in a small box inside the benching system. The next module is the CC3200 based Mqtt system. Now this is a true IoT system wherein the CC3200 is transmitting to the internet to iot.eclipse.org to port number 1883. and I have an MQTT lens running on my laptop which is subscribing to the posts. I can basically vary the frequency that I'm generating because the this is a drop-in emulator for the weather system or weather station available from, say, sparkfun.com or some other place. The rain as well as the wind speed is basically converted into a frequency. Now if I disconnect this and connect it to the CC3200, it's easy to see. Let me zoom in, and now you can really see that the see, it's updating those values on so depending upon I'm gonna really lower it down, so now it's gonna give me a smaller value in about there we go. So it's really low, and if I really turn up the potentiometer, now it's going to generate a higher frequency and it's going to update that frequency onto the system. There is an MQTT binding in OpenHub which subscribes to the posts that the CC3200 is posting at iot.eclipse.org, and all of this is happening live. So this is the true IoT power of OpenHub. Now the OpenHub is taking that data, putting it into a MySQL database, and then I can do what I want with it. I am again using charts and graphs or events, triggers, use the capability of the rules, and the possibilities are endless. Alright, the last module in my demonstration is the Raspberry Pi based robot, or the Minion Bot, which is basically a Raspberry Pi B Plus model with a Raspberry Pi camera, and it has the RPi sock. Now on the OpenHub end we have a presence indicator because using the network health binding, and I have the remote camera and remote power switches inside OpenHub. As soon as I turn on the remote camera, another menu pops up which is the rover control. Additionally, you can see that the Raspberry Pi camera LED just popped on, which tells me that yep, it's online. Looking into the Raspberry Pi control menu, you can see that there we go. I'm getting a video feed. It has a time lag definitely inside it, but it works. If I ask it to look downwards, the camera will tilt downwards and downward angle. There we go. And if I tell it to look upwards, it can look a little upwards. Shaky, and it's looking upwards. And there is definite lag in it. Alright. And as far as control goes, the amount of the precision in control is if I tell it to go forward. So I reverse the switches, and if I tell it to go forward, if I ask it to turn left, that's the right. If I ask it to turn again, turn. So yeah, there's a definite lag as far as the operation is concerned. Rotate. It's not really beautiful from behind. So move backwards. Again, rotate. Turn. One of the arms is almost fallen off. Alright, again, turn. Backward. turn right towards me. Hello. Oh, left. I'm sorry. You can turn. Sorry. My bad. Turn my way. Here we go. And look forward. Front. Turn backwards. To the camera. And downwards. Take the camera downwards and update. Take the camera upwards. And front and center. So Open Hub, Raspberry Pi, Raspberry Pi B Plus, Raspberry Pi camera, and I have an entire system working perfectly. There is a lag, definitely there is a lag, but considering all things, I think it's a good option. You know? Thank you.